Okay, hi everyone. We're back today with another lesson on duct fittings, but we're moving on from a welded fitting where there's no seam allowances or connections or anything like that. We're going to add on the main one we're going to look at is their slip and drive or S&D connection, as well as Pittsburgh or button lock seams or any of those. So if we again look at a couple sample fittings. Now these ones have an S and drive connection, and that's the hook that you see, okay, and then the raw edge that extends past that hook by 1/2 inch. And that's where these two are going to lock together like that, sort of in that sort of fashion where they connect, and we have a what's called a drive cleat go over those two hooks there, and an S cleat go over the raw edges. Okay, so when we look at a fitting with an S and drive connection, we have one end, or one side I should say, that'll butt together like that. That's the two hooks. And that gets the drive cleat. That's the drive connection. And the drive's just a 1 inch strip with, or 1 1/8 with hems, 1/2 inch hems hooked on it. Okay, and then the S cleat, we got the raw edges that lap each other like that. And our S cleat comes in here like this and connects those two. So that's our D side, and this is our S side. Okay, so when we take that to a fitting like this, you know, when we look at a piece of ductwork, it's pretty simple to calculate for the allowance needed for the drive hook. If we looked at this one, our finished size that we're always given on a shop drawing is to the end of the hook here. Okay, that's where those two will sort of butt together. So the finished size is to that 1/2 inch. Okay, so when we get a drawing like we've got on the board here, the 4x6 is the opening, and the 4-inch throat is that throat, and that takes us to this point here, which is going to be that hook. Okay, so if we looked at this sample here, when we think of that 4-inch throat, that's going to come to this edge here or this edge here, okay, to the finished size of the fitting. When you look at that on just a piece of ductwork, if I had a hook bent at each end, I just need to add on that 1/2 inch here, right? The extra material needed to bend that over, okay? But there's a little more to it than that when we get to fittings. And the rules I'm going to go over will work for radius throat, radius heel elbow. They'll work for an OG offset or a transition, or they'll work for a straight piece of duct. It's always the same rules. And even though there are shortcuts to some of the pieces within the fittings or on that straight duct, there's shortcuts, because all you got to do is add what we looked at there, the 1/2 inch on each end. If we go through and just memorize this process and use it for every part, for every piece, for every fitting, or every piece of duct, it'll always work. And once you retain that and you really learn those couple of basic steps, that's when you want to start shortcutting things, and then you can skip over some of these. Okay? So the main thing we have to do is we have to create an inch of straight for this connection here, because both of them are approximately 1 inch wide. And we refer to this as our inch of straight for our S and drive connection. Okay, now if we come back to our sample here, and this is where things get a little bit confusing. Here's my finished size here, and if I come in a 1/2 inch from that, you'll see that now I have an inch of straight there. So coming in to this point here, you'll see I have an inch here, and if I'm looking at the drive side, I've come into the back side of the hook, and I have to go a 1/2 inch out and a 1/2 inch back in to get there. That gives me my inches straight there. Okay? But from the finished side, I only moved a half an inch. Okay, so it's not always moving that full inch of straight off the bat. And if we looked at this one, let's say our hook comes in here. Okay, so I've bent a half inch back here from this edge here. I'm only moving from that bend a half an inch to get to the red line here inside, but that gives me my inches straight. And if we looked at the S side is going to come out, and this is our full 1 inch here. Okay, that's our raw edge. This is the blue line is our finished edge. Okay, so I want to come a half an inch back from my finished edge to create that 1 inch, which will eventually be there. It's not there now, but it will be. Okay, so with that being said, let's just look at how our rules to go about this. And I'm going to just erase these off, get back to my standard shop drawing, and we'll go through these rules together. Okay, the first step on any fitting, any piece of duct, is to minus through it. So that's where I'm coming from, that finished edge back to the hook side. So I'm going from here to this point here. I'm creating a line here. So I'm going to just sketch in some lines at a half an inch at each end where the air flows. So we know our air is going this way, and I've sketched in half inch here and a half inch here. Now let's see what changed on this now. My opening can't change, right? That's the most important. That's a key feature of the item. But if I look at the distance here now in the throat, I've shrunk there. It used to, the 4 inches came to this point here, and now it's shorter. And same this way, the 4 inch came here, and now it went that way. We still need a 90-degree arc, we still need a radius point and all those things, but now it's going to be based off of here. Okay, and that radius is still going to be 90 degrees, but it's only going to be 3.5 inches. Because we minused a half inch off. Okay, now the half and half didn't total each other because they're 90 degrees to one another. So half came this way, half came that way. That keeps our radius equal, but it's 3.5 now. Okay, so that's the first step and probably the most important. And as we're working through this, I want to emphasize that we have now changed this fitting. Okay, it's not a 4 inch throat anymore. It's a 3.5. So I'm going to erase the 4. It's gone. Okay, I don't want to do anything else with that. We'll see it again when the piece is finished, because if we measure from here across to our finished spot here, it still is 4 inches. Okay, but the idea is there's no arc along this edge here now. This half inch doesn't have an actual radius to it. It comes up in an arc and then it straightens. Okay, because remember, we need 1 inch of straight for an S and drive connection. So that's good. We've minused, we took off, we changed the fitting, right? Our radius is now 3.5. So if we look at this, this will work, and this will be done on any fitting. And like I said, if we went with, and let's do it over here, an OG offset. Okay, let's just sketch out an OG. And let's say it's 8 inches long, and we'll keep with our 4x6 with a 3 inch offset. So we've seen this one before. I think maybe our length was different, but the idea, it's the same fitting. Okay, so rule number 1 was minus a half inch at each end. That's the rule. Okay, so again, I'll sketch it in. I minus 1/2 inch at each end where the air flows. So I'm minusing 1/2 here, I'm minusing 1/2 here. Now what does it do to the fitting? Again, it can't change the opening. It's not going to change the offset. But in my horizontal dimension, I shrunk that 1/2 here and 1/2 here. 8's gone. Okay, forget the 8 was ever there. We're now a length of 7. Okay? If we look at just a straight piece of duct, 4x6, again, 10 inches long. Minus 1/2 at each end where the air flows through. Minus 1/2 and 1/2. This is not 10 anymore, it's 9. Okay? So regardless, we look at the fitting as the same. We take our shop drawing no matter what fitting it is or what piece it is. If it has an S and drive connection, we sketch it out. We sketch in 1/2 inch at each end where the air flows. We minus that off. We change the dimensions on the shop drawing to match that. It's a different drawing now. Okay? And then we work from that. Okay? Step 2 is to add any of our seam allowances on there. So again, let's go to the radius, throat radius, heel elbow. 4x6. And our new throat is 3.5. Okay? So when we look at our part, let's look at our sample again. Our connection point in this case is a Pittsburgh seam. And a Pittsburgh seam consists of 2 parts, a pocket and a flange. And what we know is we can't put a flange on a curve like this one. We can't put the pocket on it. We put the pocket on the heel and throat always, or the wrapper. The part that's just a rectangle, okay, because it's got a straight line that we can run that through our machine. The curve we put a flange on because we know that we can burr an edge on a disc, and that's the same operation we have here. So if we remember that we're always going to put a flange on the cheeks, and we're going to put the pocket on the heel, throat, or wrapper, the other part, then that's good. So if we look at, again, our shop drawing here, we've minused off our 1/2 inch because we got a shortened throat here from our original. And I know that in this case, I got my cheek. I'm going to have a flange this way, and I'm going to have a flange in here to connect that cheek to the heel and throat. There's my Pittsburgh. You can see my tail's been hammered over onto the flange. Flange went inside the pocket and went in there. And then you can see along the heel here, from the roll form machine, I have the machine lines and the bends that made that pocket up. Okay, so the cheek, always a flange. Heel, throat, wrapper is always the pocket. Okay, so we want to remember those. Pocket for the heel, throat, flange for the cheek. Okay, and we're really trying to envision where those parts are, where those allowances are put on. Okay. Our third step, our next step, is to do any calculations that are required for the part. And this is where we're actually starting to come up with our blank sizes. So this was 4x6. This was shrunk down to 3.5. Now calculating can be as simple as just adding numbers up. That's what we're going to do for the cheek of this one. Or it could be calculating the heel and throat, and then we're going to use a mathematical formula. Okay, the important part when we're calculating is that we use the smaller, the new numbers that we've calculated, so be it the length if it was the OG offset, or the throat radius, because we use this number to calculate the heel and throat, we need to use the shortened number now to calculate everything out, okay? In this case for our cheek, we know that we have our flange here and our flange here. And my calculations are just adding. We're going to say this is a 3/16 flange. We know that the opening here is the 4. There's another 3/16 here. Okay, so if I'm adding this 3/16 plus 4, this 3/16 here is included in the 3.5, which takes me from this point all the way out to the edge here. So I don't need to account for it. It's inside the throat dimension, so it's accounted for there. So that one we don't need to worry about, even though it's there, and we're gonna leave it on the fitting when we cut it out. We don't need to add any extra. This one goes outside, so this one we do. So we get, as we're adding that up, 3/16 plus 4 plus 3.5. And that works out all the dimensions we have there, okay? If we look at the heel and throat, we know that our number is pi times diameter, or formula, times the angle over 360. Okay, so we're going to punch that through the same way, but we're going to use 3.5, not the 4 that we were originally given. Okay? Radius times 2 times pi times 90 divided by 360. That gets us the length of these curves. Okay? And it's still just the blue line. We don't need the curve out at the flange here. Okay, so that's step 3. If we're doing an OG, if we're looking at an OG offset for this step, okay, we've shrunk down. We came in 1/2 inch on each end. And maybe our length is 7 here. And we'll still go with the 4x6 with a 3-inch offset. My cheek size, I got my 7 here. Okay, I need to use that one. Going this way, I have the 4 plus the 3. And again, I have to think about my seams. I got a seam on the cheek. I got a flange here that I have to add on. So now I'm 3/16 here, plus 4 plus 3, and this 3 actually comes in from here. So we got another 3/16 to account for here. Okay, so 4 plus 3 is 7, plus 3/16 and 3/16 is 3/8. 7 and 3/8 that way. So we're adding things up just as we did in the welded fittings. Okay, but we're adding a couple extras. We're adding the seams here, and we're using a different length. Okay, if we're punching in the wrapper formula, we add length associated with that. We need to use this shortened length in that formula. We can't use the old one. That's why I highly recommend you cross it out and write in the new numbers as a length or throat radius, whatever it may be, and use that one through any formula that you're going through. Okay? Our last step is add 1 inch at each end where the air flows through it. So remember back to our first step was minus 1/2, and that brought us back to here. We came from this edge here. We minused 1/2 to get us to here. And then we're going to add 1 on. And this is adding our inch of straight. Okay, this is actually creating them inches straight. So when we, again, look at our shop drawing here, 3.5, we want to actually add 1 inch of straight at each end here. Okay, so we have 1 more inch to add to everything. So if we think we had our 3/16 over here and in here, and now we've added our 1 inch to it. 3/16 plus 4 plus 3.5 plus 1 gets us our complete blank size. Okay, for the heel and throat, we went 3.5 times 2 times pi times 90 divided by 360. That got us to here and here. Plus 1 plus 1. So we add 2 inches to that. Same with the wrapper length. We punch in the formula that we had. That got us through our double curve. Okay, that got us to there. Now we need to add 1 inch of straight at each end where the air flows through it. So the wrapper formula, this was the formula, got us from here to here. And then we're going plus 1, plus 1. We're adding 1 inch of straight at each end where the air flows through it. The length will also, if we looked at the cheek length, we'll need 1 and 1 added onto it. Okay, and then everything else is the same as we did for the welded fitting. Okay, so to sort of sum it all up, we take 1, we minus 1/2 inch off each end where the air flows through. We then add on any seam allowances we need for the Pittsburgh connection or whatever type of seam we're using. We add those on. Then we do any calculations. We calculate out the cheek size. We calculate heels, throats, wrappers, all those types of things. And lastly, we add 1 inch to each end where the air flows through it to get our blank sizes. So we minus 1/2, add 1. Okay? And it's important that we use that shortened number for all of our calculations. So anywhere we're inputting it into a formula, be it Pythagoras for a transition or the arc length formula or the wrapper formula, we need to use the shortened length. Once we have that, let me just sketch a blank size quickly. Now we get to our actual layout of that part. We have a blank size calculated now. Now I'm going to work everything in reverse when I do my layout, as from the 4 steps we did here. My last step was add 1 inch. So the first thing I'm going to do is I put my arrow on, and this one is a radius throat, radius heel, elbow. The first thing I lay out is 1 inch of straight at each end where the air flows. Okay? 1 and 1. Next, seam allowances. I needed a 3/16 flange here on the outside and here on the outside. I lay those out. So I'm working backwards. Then I can mark my opening and the 3/16 that I needed on the inside for the throat. And now I have all my arcs that I'm going to swing. I have 2 extra ones this case because last time I swung it from just the opening when we didn't have any allowances added onto it. Now I have the outsides where the flange is. Okay, so from any of the fittings, be it again the OG, the square throat, square heel elbow, or this one, now it's the same. Just pretend that these are not there. Went to the corner of the metal with our dividers. That's our radius point. It's still, this one has moved because of the inches straight. Our radius, our arc is now inside here. And I'm going to open up my dividers all the way to here. And I swing an arc from point 1, from point 2. Then same radius point, stretch all the way out. And I hit point 3 and all the way to the outside. And hit point 4. Now that becomes our layout for this one. Square these lines up through the outside. There's our fitting now with Essen drive and Pittsburgh seams.